Hello, my name is John Kenneth D. Escalante. I will report basic traffic stream models. The terminologies involved will be the space mean speed is the average speed of vehicles traveling a given segment of roadway during a specified period of time and is calculated using the average travel time and length for the roadway segment. An example of the space mean speed by obtaining the distance covered is using rate. Using that, D1, taking each of the cars distance taken, then average it, then divide by time, we can get the space mean speed. Density or traffic density is a measure of the number of vehicles on the roads in an area. Jam density refers to extreme traffic density when traffic flow stops completely. Free flow is the rate of free moving vehicles is a vehicle that travels at their desired speed without any influence from other vehicles within the same traffic stream or in the opposite traffic stream. Flow is the rate at which vehicles pass a given point on the roadway. Speed density model. Using the formula or the formula obtained, space mean speed is equal to the free flow times 1 minus the density over jam density. The graphical model is where at zero density, the speed of the cars will be at free flow. When they reach the jam density, the speed of the cars will become zero or approaching zero. Flow density model. The formula for this is maximum flow is equal to the free flow times jam density over 4. At zero density, the flow will be zero. And at maximum density for the highway, that flow will be at maximum flow rate. And at jam density, the flow will be zero. The derivation of flow density model or the formula is using the speed density formula. By distributing U is equal to Q over K, or space mean speed is equal to flow over density, we can obtain the equation flow is equal to free flow times density minus density square over jam density. Differentiating the equation, we get maximum density over jam density over 2. Substituting the equation we got to the speed density formula, maximum space mean speed is equal to the free flow times the quantity of 1 minus jam density over 2 jam density, 2 times jam density. Simplifying, we get the maximum space mean speed is equal to the free flow over 2. Substituting those two equations we got to the maximum flow is equal to maximum space mean speed and the maximum density, we get maximum flow is equal to free flow times jam density over 4. Speed flow model. The formula for this is flow is equal to jam density times the quantity of space mean speed minus space mean speed square over free flow. The speed flow model, where at flow 0, there will be two possibilities. It either be at jam density or the cars are at free flow. And as flow increases, reaching to Q cap, maximum flow, we get the average space mean speed. The derivation of speed flow model is obtained by using the speed density model. Rearranging the equation to isolate density, distribute density is equal to flow over space mean speed, we get flow times is equal to kj, jam density times 1 minus space mean square all over free flow. Application of speed flow density relationships. A study of free flow at a particular site has resulted in a calibrated speed density relationship as follows. will be u space as the speed is equal to 57.5 times the quantity of 1 minus 0.008 density. From this relationship, find the free flow speed and jam density. B. Determine the capacity of the site. A. From the equation, 57.5 times 1 and the quantity 1 minus 0.008 times density is related to the speed density formula. We can therefore equate K over Kj, density over jam density is equal to 0.008 times density. Uh, Obtaining that, we get jam density is equal to 125 vehicles per unit distance, and the free flow will be 57.5 unit distance over unit time. At B, distributing the values we got obtained from A, we can simply get, using the maximum flow rate, 1796.875 vehicles per unit time. The second problem will be a section of highway is known to have a free flow speed of 55 miles per hour and a capacity of 3,300 vehicles per hour. In a given hour, 2,100 vehicles were counted at a specified point along this highway section. If the linear speed density relationship shown applies, what would you estimate the space mean speed of these 2,100 vehicles to be? First, obtaining the job density using a flow density model where distributing the values of 3,300 for maximum flow and the free flow to be 55, we can get the jam density 240 vehicles per mile. Using the equation for the speed flow model, rearrange the equation to obtain a quadratic equation. Then distributing the values 240 for jump density, 55 for free flow, jump density again for 240, and the flow rate to be 2100. Using the quadratic means or quadratic using in the calculator or using the quadratic formula, we can get 44.08 miles per hour or 10.92 miles per hour, which are both feasible in a highway. Thank you.